Hello. Section 3.4 has some interesting problems, so I wanted to work some of these homework problems for you so that you can make sure you're on the right track with stuff. The first problem from my math lab says a charter flight charges a fare of $300 per person plus $5 per person for each unsold seat on the plane. If the plane holds 100 passengers and if X represents the number of unsold seats, find an expression for total revenue received for the flight. So let's kind of think about this. To get revenue, we have to multiply the quantity times the price per ticket, right? So if we sell 100 tickets, then the person or the flight is $300, right? Now if we sell only 99 tickets, there's one seat that wasn't sold, so the flight is now $305 per ticket. If we sell 98 tickets, then the price goes up to $310. So what's happening? As we decrease from 100, so if we decrease by X, our price is increasing by $5 per decrease. And so our price now is 300 plus 5 times X. So our total revenue is the product of these, right? 100 times 300 would be $30,000. 99 times 305 is $30,195. 98 times 310 is $30,380. Isn't that interesting that the fewer tickets they sell, the more money they make? So our revenue function then would be R of X, which is equal to 100 minus X times 300 plus 5X. So you can distribute to get what? This would be 30,000 plus 500X minus 300X minus 5X squared. So if you put it in standard form and combine like terms, it would be negative 5X squared plus 200X plus 30,000. Okay? And which one is that? The first one? Yeah, A. Now then you can even go on to find out how many tickets would you have to sell to maximize your price, right? This is a parabola that opens down. And so if we wanted to figure out how many tickets did we need to sell to maximize the price, we would need to find the vertex. And so like we would have to do negative B over 2A, which in this case would be negative 200 over negative 5 times, 2 times negative 5. Okay, I put in my A first, sorry about that. So that's negative 200 over negative 10, which would be 20. Now understand what X represents. X is a number of unsold seats. So the company would have a maximum revenue if they had 20 unsold seats. Okay? Now, number 2, if a person shoots a basketball overhand from a position 8 feet above the floor, then the path of the basketball through the hoop can be modeled by this parabola. Y is equal to negative 16x squared over 0.434v squared plus 1.15x plus 8, where v is the velocity of the ball in feet per second, y is the height of the hoop, and x is the distance away from the hoop. If the basketball hoop is 10 feet high and located 12 feet away, what initial velocity v should the basketball have to go through the hoop? Okay, so let's think about this problem. We need to plug in some things so that we only have one unknown, right? So what do we know here? V is a velocity, which we're trying to find that, right? We don't know what v is. But we do know the hoop is 10 feet high. So y is the height of the hoop. So in place of y, we're going to put 10. What is x? X is the distance away from the hoop. So we were told that we are 12 feet away. So the value of x is going to be 12. So y is 10 and x is 12. So we would have negative 16 times 12 squared over 0.434v squared plus 1.15 times 12 plus 8. Okay, going to need to get out your calculator here. So we would have what? Negative 16 times 12 squared, which is 144, is negative 2304 over 0.434 v squared plus, what is this, 1.15 times 12 is 13.8 plus 8. So now if we combine like terms, we will get 10 is equal to negative 2304 over 0.434 v squared plus, we combine 13.8 plus 8, that's what, 21.8? Okay. Now we need to just get this solved for v squared. Maybe we'll subtract the 21.8 first to get a negative 11.8 equals negative 2304 over 0.434 v squared. Now, do you remember the rule of fractions? You can multiply by the LCD, or in this case, since we have just two expressions equal, we can cross multiply. So if we multiply negative 11.8 times 0.434 v squared, we would get negative 5.1212 v squared is equal to negative 2304. So now we can divide both sides by negative 5.1212. And running out of room, so we would get v squared is equal to 449.89. So what is v equal to? V would be the plus or minus square root of that. Okay, I'm just going to say that there. And so the square root of that value is 21.21. So we'll say v is approximately 21.2. So round to the nearest hundredth. So I need 21. Okay. So the initial velocity should be about 21 feet per second. Number 4, to determine the appropriate landing speed of a small plane, the formula d is equal to 0.1s squared minus 3s plus 22 is used, where s is the initial landing speed in feet per second and d is the length of the runway in feet. If the runway is 800 feet long, what is the appropriate landing speed? The key to these problems, especially when you're given a model, is just understanding what the variables represent. D in this case was the length of the runway, so we're told that, right? We're told that D is 800 feet. What is the appropriate landing speed? That is what we don't know. So to solve this, we're going to put it in a quadratic equation, replacing D with 800. And then we need to solve this problem. To solve it, we would subtract 800 from both sides. So when you do 22 minus 800, you're going to get a negative 778 is equal to 0. Now if you want to clear out those decimals, you can, but really we could just plug into the quadratic formula and get our answer. So we would have s is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, what is our b value? Right, b is negative 3. What about A? A is 0.1. And lastly, C is negative 778. Oops, I made that one too small here. So simplifying this, we're going to get the opposite of negative 3, which is 3 plus or minus the square root of 9. And then calculate this. We've got to do 4 times 0.1 times 778. And notice what our sign is. A negative times a negative would make this plus 311.2. And that's all over 0.2. So we would have 3 plus or minus the square root of 320.2 over 0.2. You can let the calculator simplify this for you. You don't have to do that, but we've got to do 3 plus the square root of 320.2 over 0.2 and 3 minus the square root of 320.2 over 0.2. Now you might guess this square root of 320 is going to be what? It's going to be more than 3. So when we subtract that off, it's going to be a negative value. So that one won't make sense in the context of this problem. So we really just need to find that first value, 3 plus the square root of 320.2, and then divided by 0.2. And that gives us approximately 104.5. So that means the landing speed needs to be 104.5 feet per second. Number 5, kind of similar, just changing the letters and what they mean. The sales of sport utility vehicles in the U.S. in millions can be modeled by the quadratic function shown here. X equals 0 is 1990, X equals 1 is 1991, and so on. Use a model to approximate sales in 1997. So this one's a little bit different because what do we know? What does 1997 tell us? It tells us the value of X, right? X would be 7 in this case. So to solve this problem, the only thing we have to do is plug in 7 for X. So don't try to make this into a more complicated problem. Okay. So f of 7 would be 0.016 times 7 squared, or 49, plus 0.124 times 7, plus 0.787. And my calculation gives me 2.439. Now it said round to the nearest tenth, so that would be just 2.4. So that would tell me that there were 2.4 million SUVs sold in 1997, according to that model. Now, one last problem is the number of international mutual funds has grown since 1984. The table to the right shows the year and the number of such funds. Answer the following questions. The first part I did not put in here, but it was just to choose which graph represents the data. And you might can tell this, right? As you increase in the years, you're increasing in Y. So this graph should be increasing or rising from left to right, which would be this one. And if you wanted to, you can input that into the calculator. Do you remember, go to Stat and Edit. And you can enter your year in L1 and the funds in L2 and choose an appropriate viewing window. And then you would have to turn on your stat plot, and you can see all that. And I'll go through that with you in just a minute. Let's go through the second part, and then we'll go back to that. Now, the interesting part here is to find a quadratic function of the form f of x is equal to a times x minus h squared plus k that models the data. Use 0, 13 as a vertex and 11, 366 as the other data point to determine a. So we did this in the lecture video, but just think about what we would have to do here. If we are using the point 0, 13 as a vertex, that means h is a value of 0, right? and k is 13. So this is really going to simplify rather nicely to just be a times x squared plus 13. So what I need to do now is plug in the x and y value that they told me to use so that I can solve for a. So the x and y value they told me to use was here. So x is 11 and y is 366. So we would get 366 is equal to 11 squared, which is 121a, plus 13. So now we can subtract 13 from both sides to give us 353 is equal to 121a. And now divide by 121. And so we get 2.9, roughly 2.92, is the value of a. So the quadratic function that models this would be y is equal to 2.92 x squared plus 13. Okay, so I went back to plug in the value of a here. Now, if you want me to remind you how to do this stat menu to enter these points, if I go to stat and 1 and clear out anything that you might have in your list, so remember we can enter the years in L1, and I might say, yeah, you can even see the graph that they have drawn. Use 0 for these year 1984 and so on. So 0, then 1, 2, are those all consecutive? Yep. 3, 4, 5, 6, 7, 8, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, then use the right arrow key, and then we can enter these 13, 24, 35, 47, 59, 75, 95, 128, 134, 196, 288, and 366. Okay, good. If you get an error message that says dimension mismatch, that's usually because you have one off in your L1 and L2 columns. Now, if I wanted to plot that, I have to do second and stat plot. I've got to turn this on, right? And I'm going to do a scatter plot and use the little square to mark the point. Now, the thing that I need to change first is my window. My x values went from 0 to 12, so maybe you want to do from 0 to 15 or 20. It doesn't really matter there. A scale of 1 is okay. If you want to use 2, that's fine. Now our y values do what? They're all positive. They go to 366, so maybe we'll say 400. Oops. And our scale, I'm going to do 50. And now we can graph. Okay, and that would be the graph that you would be selecting, and that's the one we see here. Now, your calculator does quadratic regression. If you wanted to get that further, you can, but that's not really the point of this particular problem. I'll go into that with the calculator video that I show you. Okay, but that's good for the homework. If you have any questions, please contact me. Thanks.